Hello and welcome to this video on mesh analysis. Mesh analysis is similar to nodal analysis in the sense that it is a more systematic technique than some of the others which have been discussed in previous videos, such as applying KCL, KVL, or voltage dividers and such. It's systematic in the sense that if you apply it correctly, you can get the right answer to almost any circuit. And you'll end up with a series of a system of equations that you'll need to solve. So, like nodal analysis, you need to have an equation solver available, whether that's you doing it by hand or some handy online tool or your calculator. So, let's see if we can bring up the steps of mesh analysis. So there's basically 4 steps. The first is to identify the meshes in your circuit. And if we go back to this circuit that we've drawn here, the meshes are basically, if you were to think about it, holes in the circuit that are completely surrounded by wires and components. So in these dashed red lines, I've drawn the 2 meshes in this circuit. Again, they're basically, in a sense, they're the holes in the circuit. Now, one thing you need to be careful of is that when you're defining a mesh, so for example, the components of this first mesh on the left would be the 4-volt source, the 1 k ohm resistor, and the 2 k ohm resistor. You need to make sure that everything is connected. I can't have wires crossing over each other without being connected when I'm defining meshes. And in fact, this is one of the limitations of mesh analysis, is there are circuits that you just can't find the meshes for. Okay, so the first thing to do is to identify the meshes, which we've just done. The next step is to assign mesh currents. And the idea here is we will assign currents that flow around each mesh. In some cases, these are not the actual currents flowing through the components, but they're part of the current that flows through a component. So if we go back to our picture, or our circuit, we'll assign 2 mesh currents. We'll assign this current here, and we'll call this I1. We'll decide that this is mesh 1. And then, let's see, what's another color? We'll choose a second current and call this I2. Now, it's helpful to be consistent here and either assign all of your mesh currents to be clockwise or all of them to be counterclockwise. You can assign the mesh currents to go, one to go clockwise and one to go counterclockwise, but it makes things a little bit more complicated. So I've just assigned all of the currents to go clockwise. So that's pretty much step 2. So we're already halfway done, and this hasn't been so bad, has it? Now the next thing we need to do is apply Kirchhoff's voltage law around each mesh. So let's go back and start with mesh 1. Okay, so we'll start with this mesh current that we've defined, and we'll apply Kirchhoff's voltage law around the mesh. We'll start at the source, and since I'm going, we'll apply the voltage law in the same direction as we've defined the mesh current. So I'm going here from negative to positive on this source. So Kirchhoff's voltage law will give me a minus 4 volts. And then I get the voltage across this 1 k ohm resistor. We know from Ohm's law that will be 1 k ohm times I1, whatever I1 happens to be. We don't know what I1 is yet, but by the time we're done, we'll have 2 equations and 2 unknowns, I1 and I2, and we will solve them. Okay, now things get a little weird. I need to find the voltage across the 2K ohm resistor. But the thing that makes it weird is I have mesh current I1 flowing this direction and mesh current I2 flowing this direction. Now clearly, in this case, I1 or I2 are not the actual currents that flow through the 2K ohm resistor. Instead, we think of them as virtual currents. And in fact, what we will do is we will take the 2K ohms that our resistance is, and we'll multiply it by I1 minus I2. Okay, this I1 minus I2 is the net current flowing in this direction. So that's actually the weird part about mesh analysis. If this last step made sense to you, then everything else will be easy. Again, conceptually, the idea is we look at the actual current flowing through a resistor as the sum of these virtual currents. And since we're applying KVL around the mesh 1, we're done. We can say that this is equal to 0. And we can rearrange this a little bit. We can factor out an I1 and move the 4 volts or negative 4 volts over to this side. And we get then I1 times 1K ohm plus 2K ohms minus I2 times 2K ohms is equal to 4 volts. Okay, so that gives us one equation and two unknowns in I1 and I2. Let's do the same thing and apply KVL, Kirchhoff's voltage law, around the second mesh. And I guess we'll start here at the, we'll start here with the proper color. We'll start here at the 5 volt source, and we're going from plus to minus as we go through the 5 volt source. So that's 5 volts. And then we come around the bottom of the mesh up to this point, and we now have going from plus to minus. You'll notice that I changed the sign on the voltage when I'm looking at it for mesh 2. So I'm going to have 2K ohms, that's my resistance, times the net current, I2 minus I1. Again, I get that by looking at the two virtual currents that are flowing through this resistor. And then finally, the 3K ohm resistor, I'll have plus 3K ohms times I2, and this will equal to 0. And again, I can do some simplification on this. So I have minus I2 times 2K ohms plus, whoops, got that one wrong. Don't want to have this be I2, we want this to be I1. Okay, plus I2, 2K ohms plus 3K ohms. And we'll move the 5 volts to the other side, and we have minus 5 volts. Okay, so basically what we've done here is we now have one equation, the second equation, we have two equations and two unknowns. So we're finished with step 3. Step 4 is to solve our system of equations. So basically what we need to do then is solve the system of equations. And to do that, I will use Wolfram Alpha, which is currently my equation solver of choice. You can use whatever you want. It could be your calculator, MATLAB, however you want to solve these equations. Go ahead. Okay, so the first equation will be I1 times 1K ohm plus 2K ohms minus I2 times 2K ohms. So we have, and I think I'm going to change this from I1 to just A1, because alpha tends to think of I as the square root of -1. So we have A1, which stands for I1, times 1 k ohms plus 2 k ohms, minus A2 times 2 k ohms, and this is equal to 4 volts, if I've done that correctly. Whoops. Now we'll just flail around a bit trying to find our... Okay, so we had I1 plus times... Okay, yeah, it looks like I did it correctly. Now we'll do the second equation. So we have minus A1 times 2 k ohms plus A2 times 2 k ohms plus 3 k ohms, and this is equal to minus 5. So if I put these in correctly, we hit return, and alpha gives us, wow, even a plot of the solution set, gives us a solution in approximate form. That gives us a numerical solution, and you can see from this that A1, which is what I called I1, is going to be 0.909 milliamps, and A2 is going to be minus 0.636 milliamps. Okay, so if we go back to our circuit diagram, we have now that I1 was 0.909 milliamps. I2 is minus 0.636 milliamps. Okay, so in a sense we're done, but just to make clear that there are now things we could compute. So for example, in the original circuit I had drawn this I, and so if I want to find what that current is, well, if we look at it, I is equal to I1 minus I2, okay, because I have a I1 going this direction, I2 going this direction, and so I could work that out and get that it is, let's see, we'll work this backwards, 1.545 milliamps, if I've worked that correctly. I could also ask, what's the voltage across this 1 k ohm resistor, for example? Suppose I need to know that. Well, that is going to be 1 k ohms times I1. So that will be 1 k ohms times I1 will be 0.909 volts. Okay, so that pretty much wraps up the introduction to mesh analysis. Now, we've done the very simplest case we could. It turns out mesh analysis is easiest if you have only independent voltage sources. So I've got this independent voltage source and this independent voltage source. Once I add current sources to the mix, things get a little complicated. This is essentially similar to what happens in nodal analysis. Nodal analysis, independent current sources are easy. Voltage sources, we have to introduce supernodes. In mesh analysis, independent voltage sources are easy. With current sources, we'll have to introduce super meshes. And we'll do that in the next video. So hopefully this has been helpful and informative, and thanks for watching.